Okay, so for today, we're taking all of the properties from the last lesson and then putting them together into one problem. So we're going to take this logarithm and condense it down into a single log answer. We're going to use all of our properties to do that. So we have 2 log of 6 minus log of 9. All right, so you have to start with this coefficient. And remember, coefficients become exponents with m. So this one is going to become log of 6 squared minus log of 9. All right, now we're going to change this 6 squared into log of 36 minus log of 9. And now we can use the quotient rule because we have subtraction. So it becomes log of 36. Oops, not that way. We have log of 36 divided by 9. So then 36 divided by 9, we know is 4. So our final answer is log of 4. So for 20, we have 4 log base 4 of A plus 2 log base 4 of B. So first deal with your coefficients and rewrite it as log base 4 of A squared plus log base 4 of B squared. And now we have addition, which means it's the product rule. So you're going to rewrite it as log base 4 of A squared times B squared. And because these are different bases, we have nothing further to simplify. So you can rewrite it without the parentheses and the multiplication sign if you would like, but you do not have to. So for 21, we have 7 log base 4 of U minus 3 log base 4 of V squared. So exponents first. So log base 4 of U to the 7th minus, now for this one, you already have an exponent here. So you're going to multiply them and get log base 4 of V to the 6th power. And now we have subtraction, which is the quotient rule. So we have log base 4 of U to the 7th over V to the 6th. Because these are different bases, we are done. And that's our final answer. All right, so for our next one, we have multiple logarithms, and you just go left to right. So we have log base 2 of 15 plus log base 2 of 4 minus log base 2 of 6. So start with these two. And since it's addition, it's the product rule. So we have log base 2 of 15 times 4 minus log base 2 of 6. So then 15 times 4 is 60. So we have log base 2 of 60 minus log base 2 of 6. So we're at subtraction now, which is the quotient rule. So we have log base 2 of 60 over 6. So 60 divided by 6 is 10. So our final answer is log base 2 of 10. So our next two, we have log base 3 of 4 plus log base 3 of y plus 1/2 log base 3 of 49. So let's just start left to right and deal with our exponent at the same time. So we have log base 4 plus log base 3 of y. So you multiply 4 times y. So we have log base 3 of 4y plus log base 3 of 49 to the 1/2 power. Now briefly, we talked about the 1/2 power in the last set of notes. So the 1/2 power is the square root. So now the square root of 49 is 7. So it becomes log base 3 of 4y plus log base 3 of 7. And now we can condense this. Since it's plus, it's a product rule. So we're going to do 4 times 7 and get 28. So we have log base 3 of 28y. And that is our final answer. All right. We're just going to go ahead and skip this one and go to 25. Okay. So we have 3 log base 2 of 4 minus log base 2 of 32. So go ahead and make your exponent so that we have log base 2 of 4 cubed minus log base 2 of 32. So 4 cubed is 64. So we have log base 2 of 64 minus log base 2 of 32. Since it's subtraction, it means we're going to use the quotient rule. So we're going to do 64 divided by 32, which is 2. So we have log base 2 of 2 as our final answer. Okay. Now, we have 2 log of 6 minus 1/4 log of 16 plus log of 3. We're going to talk about this 1/4 power. So if 1/2 is the square root, 1/3 is the cube root, 1/4 is the 4th root. So when we do this, we need to figure out the 4th root of 16. So we need a number that when you multiply it 4 times equals 16. So the 4th root of 16 is 2. So over here we have log of 36 now because we did 6 squared minus log of 2 plus log of 3. So you're going to start with the subtraction. So 36 divided by 2 becomes log of 18 plus log of 3. And so since now we have addition, we're going to use the product rule. So 18 times 3. So we have log of 54 as our final answer. All right, so now we're going to expand the next 6. So we're going to start with a single log and expand it as we go. So we have log base 6 of x, y, z to the 4th power. Now each one is its own individual base, and they're all multiplied together. So we're going to use the product rule. So it becomes log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th power. All right, so we're not quite done because we have the z to the 4th power. And because it's an exponent, it becomes a coefficient in front of the log. So we have log base 6 of x plus log base 6 of y plus, and this is where the exponent becomes a coefficient, 4 log base 6 of z. And that is our answer as an expanded form. So for 28, we have division. So a to the 9th is the entire numerator, and b is the denominator. So it expands to log base 4 of a to the 9th minus log base 4 of b. And because we have this exponent of 9, it becomes the coefficient in the next line. So we have 9 log base 4 of a minus log base 4 of b. There is the final answer for 28. So 29, we have now an exponent outside of our set of parentheses here. So that 2, that is our exponent, is becoming the coefficient in front of the whole problem. So we have 2, and then we're going to use a square bracket just to have less parentheses. And we're going to move to this q to the 4th times r squared. So since they're multiplied together, we're going to use the product rule. So we have log base 7 of q to the 4th power plus log base 7 of r squared. We're going to enter brackets there. Now our next step is to deal with the exponents here and put them as coefficients in front of the log. So we have 2 and then 4 log base 7 of q plus 2 log base 7 of r. And there's our final answer. Now for 30, this 2 becomes our coefficient just like in 29. It goes outside the brackets. So we have 2 in the brackets. And then it's the quotient rule. So we have the numerator divided by the denominator. So we have log base 2 of y minus log base 2 of z to the 5th power. And then this exponent is going to become the coefficient. So we have 2 log base 2 of y minus 5 log base 2 of z. And that's our final answer. All right, so for this one, we have log base 7, or just we have the common base of the square root of 7x cubed. So we're going to change the square root so that it becomes log of 7x cubed. And then remember, square root as an exponent is 1/2. And now that 1/2 becomes our coefficient in front of everything. So that we have 1/2 and then the square brackets. And then we're going to split this up. So we have log of 7 plus log of x cubed. And then we have that one last step of dealing with this exponent. So it becomes 1/2 log of 7 plus 3 log of x. And that's our final answer. And now for 32, we have log base 3 of the 4th root of m to the 5th n squared. So we're going to change the 4th root into a fraction just like we did over here. If the square root is 1/2, the 4th root is 1/4. So we have log base 3 of m to the 5th n squared to the 1/4 power. And now this 1/4 becomes our coefficient in the next line. So we have 1/4, and then we're going to split these up again. So we have log base 3 of m to the 5th plus log base 3 of n squared. And then our next step is just dealing with the exponents. So we have 1/4, 5 log base 3 of m plus 2 log base 3 of n. And there you go. That's our final answer.